Notes. Yesterday we talked about the unit circle, which we already know, sine, cosine, tangent, and yesterday we incorporated secant, cosecant, and cotangent. Sine, over here in this box on our notes today, let's go ahead and put that sine. Oh, classic, right? Classic, Mr. Collier. Sine is y, cosine is x, and tangent is y over x. Now let's also put in this box that sine is 1 over which of the other three? Is it cosecant, secant, or cotangent? Cosecant, right. No coco, the cosine cosecant matchup unfortunately does not work. Then we have 1 over secant, and tangent is 1 over cotangent, right? And we did that for the homework. Basically, if you want cosecant, just work with your sine and flip it upside down. Also, when it comes to these, sines and cosecants are positive and negative in all the exact same quadrants. So in this quadrant 1, everybody's positive, which means everybody's positive, even upside down. In this second quadrant, right, we talked about a smart trig class. If this is the sine, it is also the cosecant quadrant, where the cosecant is also positive, because when you flip something upside down, it doesn't change the sign, all right? It doesn't change it from positive to negative or the other way around. Now, what are we trying to learn today? The truth is we're a little bit ahead. We've worked a little bit harder, maybe not. We've worked a little bit faster, let's say, than some of the other trig classes. And today's objective is to try to use only the first quadrant of the unit circle, right? In the long run, when we're doing trigonometry in 2 months, right, and it's December and we're about to go to, holiday break or whatever, we probably don't want to have to be memorizing and remembering the entire unit circle, because we talked about how the unit circle is super repetitive, okay? We talked about how straight across, God, he's done it again, how straight across all of these things are exactly the same. Or if you follow the diagonal, all of those, or straight up and down, so there's all of this repetition on the unit circle. And so today, we're just gonna talk about how can we take advantage of that repetition. And so we're gonna be thinking pretty much exclusively of the first quadrant over here. Now, we definitely all have these memorized, and typically we've kind of written those down and then spread them around, but before yesterday's notes, I said 10 days, you have a test with no calculator and no unit circle. And now it's only 9 days. So find the exact values of sine of 135, okay? So sine of 135 is in the second quadrant. That's pretty easy for me to understand. That's gonna be over here in this second quadrant. Is sine positive or negative in that quadrant? Positive, a smart trig class. This is where the y values are positive. That's where sine's positive. So we know it's gonna be positive. And now we just need that fraction. And what we're gonna basically be thinking about today is, can we think about this using quadrant 1, which means can we kind of come up with which angles match together, right? So if I make a little list here, all 4 of these are matches. They go straight across, they go straight up and down, they go diagonal, and all 4 of those match with, in the first quadrant, 45 degrees. And what is the match in the second quadrant? 135. And what about the third quadrant? 225. And what about in the fourth quadrant? 315. All 4 of those are matches, and they all have the same exact 2 pairs. These are the easy ones. Square root 2 over 2, square root 2 over 2. Over here, square root 2 over 2, square root 2 over 2, square root 2 over 2, square root 2 over 2. Obviously, we have those negatives added in, okay? So whenever we think about 135, I don't really need to be thinking about this area 135. I can use my brain, I can think about 45. So what we're trying to do today is basically just connect these 4 degrees in our head, just kind of connect them together. So when we see a 135, we can just say, oh, let's think about 45. Now, the last thing before we actually finish the question here, trig, prob stats, unit circle, part 2, quadrant, whatever, use the reference angles. So everything that we just said is a thing. They're matching pairs. They're a group because of reference angles, okay? All of these all share the same reference. 45 has a 45-degree reference angle, and 135, 45 degrees, and 225, 45, right? They all share, and when you all have the same reference angle, you're gonna work. So we're thinking about reference angles today. We're thinking about groups. 45 is the square root 2, and so my answer here is gonna be the 4th time he's messed that up today. Square root 2, square over 2. All right, let's see if we can do this. The whole point of this is that it goes a little bit faster, not slower. So let me kind of speed up myself. Welcome back.
It was a lot.
I don't need to hear about how your trip to the bathroom went. I'm just glad you're back. All right, cosine of negative 210. Honestly, I don't really like negative, so let's do a coterminal. Negative 210 plus 360 is equal to 150. All right, so I'm really thinking about the cosine of 150. Now, 150 is not in our first group that we talked about. It's not in our 45 reference angle group. 150, what are some other angles that match with 150? 30's right. 150 is only 30 degrees away from 180, right? So it matches up nicely with 30 degrees. What are the other ones it matches up with? 210 and 330. So let's get those down. 30, 150, 210, and 330. That's a nice little reference group. So whenever we see any of those, they're all talking about the same numbers. Now, the signs are a little bit different. So when I see cosine 150, I think about 150 is in this second quadrant. That's a smart. Sine is positive, but cosine would not be positive. So this is going to be a negative answer. Then if I see 150, I can just think about 30. 30 is right here. My cosine is square root 3 over 2. Now, again, while you're sitting here, your first thought might be, maybe this is more annoying. This almost seems longer. But remember, you're going to eventually get to the point where you don't carry the unit circle around in your back pocket. And if you can just memorize quadrant 1, or maybe just write down quadrant 1, then you can just kind of extrapolate that information all around. Lastly, 240, which is not in our list. So 240 makes up that last group. Let's go with green. Oh, that's not green. Got it. 240. And what other angles match up with 240? 60 is right. And what about quadrant 2? 120. What about quadrant 4? 300. All of those are nice buddies that match up and they group up together. Sweet. So the tangent of 240, let me go ahead and finish this nice drawing that I've been making here. Wow. At this point, you can't tell what anything is because there's too many lines on top of each other. Great job, Mr. Collier. All right, tangent of 240 is in the third quadrant. Is tangent positive or negative there? Positive, nice. And so now I just need to work with that tangent. I can think about 60 because 60 and 240 are the same. And so when I look at my 60, now here's a little bit of a life hack, right? Here's a Mr. Collier special. What I like to do is when I'm working with this, and obviously I have my parentheses, right? I like to write one extra number that floats even past these parentheses, that is the tangent. So I'll grab the y divided by x, and I'll write square root 3 like that. Square root 2 divided by square root 2 is 1. And this would be 1 divided by square root 3, which is that when we'd have to rewrite it, square root 3 over 3. That way, I don't have to keep coming back and keep calculating tangent and keep thinking about, I just write it once, and then for every tangent question, I can just grab what I need. So for 240, which is the same thing as 60, tangent is square root 3. All right, let's do this last one quickly. We've done one from each family, the 45 family, the 30 family, and the 60 family. So now let's do this one, which could be any of them. Tangent negative 135. I don't like negatives. Let's add 360, and we get 225. Which family is 225 in? The 45 family. So all I need to do is grab the 45 and get out of there. And also think about my sign. So 225 is a third quadrant number. Tangent, third quadrant, positive. Then 225 is my 45 family. So I'm gonna go here and I'm gonna grab Mr. Collier's special, this little secret tangent number that I wrote there, 1.
What's that number say beside the 240 degree?
Over here?
Yeah.
300. Okay, now, we're basically, we got 4 questions left and we're done with notes. Here's the bummer. These families that are kind of easy to keep track of, the 30 and the 150 and the 210 and the 330, that's not too bad. Well, radians come along and they kind of muck it up a little bit, okay? So let's go over here, and maybe you're keeping track of these reference angles. I would recommend you have it written down somewhere. And let's double down and let's write these with radians instead, just to have a full, complete 45 is pi over 4. And then what are all the other pi over 4s that we have? 3 pi over 4, 5 pi over 4, 7 pi over 4. What do all those have in common? They're divided by 4. So that makes it pretty obvious that they should be grouped together. Okay, now what about 30? What is the radian equivalent of 30 degrees? Is that pink easy to see? Yeah, it's pretty good. 30 is pi over 6, and 150 is 5 pi over 6, and 210 is 7 pi over 6, and 330 is 11 pi over 6. And what do all those have in common? They're divided by 6. And so let's do the very last one here, the 60 family converted into radians, which would be pi thirds, 2 pi thirds, 3 pi thirds, nope, that one reduces, 4 pi thirds, and 5 pi thirds. Now, as much as we were thinking, radians are gonna make this so weird, actually radians are like low-key easier because they're already grouped into their families based on the divisor, based on that denominator, right? It's obvious that all of these are in the same family because they literally have the same denominator, and same with the 6s and same with the 3s. Now, I have to point this out before we move on because this is the one place you'll slip up. When it says divided by 6, that matches with the 30 family. And so the rookie move is people see, oh, there's a 6 on the bottom, that must be a 60 number. It doesn't work like that, unfortunately. They're kind of opposites. So when it says divide by 3, it's not a 30 family, it's actually a 60 family. So now that we've pointed that out, we have learned everything from today, and it is time to just finish these 4 questions. Again, this is meant to be faster, not slower. So let's see how we can do. Let's get green. Okay, sine of 5 pi fourths. I want to think about the positive or negative, and I want to think about the family that it's in. 5 pi fourths is in the third quadrant where sign is negative. Then pi fourths is in the fourths family, which is 45s, and I know that the 45s is easy, square root 2 over 2. And so there you go. That's me thinking only about the first quadrant, about the positive negatives, and about kind of what family that this number is in. Up next is cosine. All right? Cosine of 5 pi sixths. 5 pi sixths, which quadrant is that in?
The third.
2. And it is cosine second a smart. Okay, this is going to be negative as well. And then pi sixths is in the sixth family, which is actually the 30s. Yeah. Square root 3 over 2. Because I know that very first 30 is 3. Right? So I hope that maybe at first you weren't sold this is going to be a little faster. And maybe it's not as fast, but if you don't have the whole unit circle built for you, it does work a little bit better. All right. Let's look at this. Tangent of 19 pi sixths. Now, 19 pi sixths, that's a huge number. If we can figure out what quadrant it's in, we don't really need to simplify this because which family of numbers is the pi sixths in? The 30. So this is the tangent of a 30 reference angle. And the tangent of the 30 reference angle is a square root 3 over 3. The one thing that we have to figure out is the sign, which might not be super obvious, of 19 pi sixths. Does anybody know what quadrant we would be in?
The third.
If this is 0 and we're talking about sixths, 6, 12, 18. So that would be 0, 6, 12, 18, 19 would be in the third quadrant. Tangent would be positive there. Or you could do your, coterminals and you could subtract your 12 pi 6, and you could do it that way if you wanted. 11, negative 11 pi thirds. Again, we know right away this pi thirds is in our 60 degree family. The tangent of 60 degrees is square root 3. We just have to figure out, well, what quadrant is that in? Because I don't know if it's supposed to be positive or negative. So there's, you can do it this spatial way if you want. 0, 3, 6, 9, 12, and it's 11. So that would be negative 3, 6, 9, 11 is right here. It would be first quadrant. It would be positive. If you don't like doing that spatial circle stuff, well, then just do the same coterminal stuff we've been doing for a while. Negative 11 pi thirds plus 6 pi thirds equals negative 5 pi thirds. Oops, got to go one more time. Negative 5 pi thirds plus 6 pi thirds equals 1 pi third. Oh, perfect. We're in the first quadrant. The answer is positive square root 3. All right, we're done with the notes. It's basically everything we already know how to do. The thing that I was tasked with trying to teach you today is think about these families a little bit, because it might make your life a little bit easier than having to go every single time to the unit circle. And the one thing that was a little tricky is that the sixths are actually in the 30 family, not the 60 family. All right, we're done. Homework time.